Chapter 3, Section D, Division of Radicals. And one thing you need to know is that a fraction is a division problem. We have the numerator divided by the denominator. And when we divide radicals, the key is we do not want a radical in the denominator. So we're going to use this rule that if the denominator contains a simple radical, such as like a square root of a, square root of some number, then we use the rule that square root of a times square root of a equals a. So we're going to work on that on simplifying radicals. In example 1, notice that we have the square root of 3. So if I can multiply this denominator by the square root of 3, then I can cancel out that radical and I can write the radical as without a square root of 3. But what I did at the bottom of a fraction, I must do the top so I can keep the equation equal. So that's the reason why I multiplied the top by the square root of 3 as well. Multiplying across, I simply get the square root of 6 divided by 3 times 3, or the square root of 6 divided by 9. That is in simplest form. Please don't make the mistake of trying to simplify the 6 and the 9. That 6 is underneath the square root, so I cannot take a 3 out of it and to simplify with the 3 and the 9. So please don't make that common mistake. For example 2, this time I have the square root of 2 in the denominator. So let's multiply the top and bottom by the square root of 2 divided by the square root of 2. Multiplying straight across, I get a square root of 2 in the numerator and 4 times 2 in the denominator, or we can write this square root of 2 over 8. And that is our simplified answer. Example 3, since we have the square root of 5 cubed, we're going to have to do a little algebra before we can actually rationalize the denominator. And that's what it is when you get rid of the radical in the denominator. So I'm going to recall that the square root of 5 cubed means I have the square root of 5 times square root of 5 times square root of 5. I can multiply 2 of those square root of 5s and get 5. And then I left over with the square root of 5. So the square root of 5 quantity cubed is equal to 5 the square root of 5 because of the following. Now that I simplify the radical, I'm ready to rationalize the denominator using the method we used in example 1 and 2. So I'm going to multiply the top and bottom by the square root of 5. Multiplying straight across the top, that gives me the square root of 5. And then multiplying across the bottom, I end up with 5 times 5, which of course is 25. So my answer to question number 3 is the square root of 5 divided by 25. Examples on the previous page, we had a single term in the denominator. Now we're going to look at what we do when we have a binomial in the denominator, something in the form of a number plus a square root. So a plus the square root of b. And to do this, what you're going to have to do is rationalize the denominator by multiplying the top and bottom by the radical conjugate. So if I have a plus the square root of b, its conjugate would be a minus the square root of b. So let's see how this works in example 4. Looking at example 4, we got 2 minus square root of 2, which is in the form of a plus square root of b. So I need to multiply it by its radical conjugate, a minus square root of b. So in this case, I got a minus square root of b, so I got to multiply by a plus the square root of b. Since I have 2 minus the square root of 2 in the denominator, the conjugate, radical conjugate, would be 2 plus the square root of 2. And what I do to the bottom of a fraction, I must also do to the top. So I'm multiplying the top and bottom by 2 plus the square root of 2. So let's just multiply across. So that's going to be square root of 2 times 2 plus the square root of 2 for our numerator. And our denominator, we got 2 minus the square root of 2 times 2 plus the square root of 2. Recall from section C, we're going to just do the distributive property on the top, which gives us 2 to the square root of 2, plus square root of 2 times square root of 2 is just simply 2. And in the bottom, we have these difference of squares, so it's just going to be the first term squared. The middle terms are going to cancel out, and we're going to end up with just the last terms squared, which would be a minus 2. So let's rewrite what we have here. We got 2 to the square root of 2 plus 2 all over 2. Now notice that I do have some in common here. I have a GCF. If I can simplify this radical down, I do want to simplify it. So I'm going to factor out my GCF of 2 from the top. That gives me the square root of 2 plus 1 divided by 2. And then 2 over 2 is just 1. So my actual answer is the square root of 2 plus 1. Okay, in example 5, I have a binomial in the bottom, so I need to multiply by the conjugate of the square root of 7 plus 2, so that's going to be the square root of 7 minus 2. What I do to the bottom of the fraction, I must do to the top. And again, I'm just going to multiply straight across to get the square root of 3 times by the square root of 7 minus 2. And then I'm going to multiply the two bottom binomials together. On the top, we do the distributive property. And on the bottom, we have the difference of squares. For a final answer of the square root of 21 minus 2, the square root of 3, all over 3. In example 6, our radical conjugate should be the square root of 10 minus 4, so let's multiply the top and bottom by that. Multiplying straight across, we have the square root of 10 minus 7 times by the square root of 10 minus 4. And on the bottom, we have the square root of 10 plus 4 times by the square root of 10 minus 4. So on the top, we're going to multiply our first terms together to get 10, our outer terms to get negative 4, the square root of 10, our inner terms gives us negative 7, the square root of 10, and our last terms multiplied together gives us positive 28. Doing the same thing in the denominator. Well, in the denominator, we have difference of squares. So that's the first term in the binomial squared, which will give us 10, minus our second term in the binomial squared, which will be 16. Combining like terms on the top, we got 10 and a plus of 28, which will be a 38. And then negative 4, the square root of 10, minus 7, the square root of 10, will equal a negative 11, the square root of 10, divided by negative 6. For our next example, the instruction is going to be write in the form of a plus b, the square root of 3, where a and b are elements of the rational numbers. So we're going to start this out the same way. We need to rationalize the denominator by multiplying the top and bottom by the conjugate, the radical conjugate. In this case, that's going to be the square root of 3 minus 2. Multiplying straight across. On the top, we're going to use our distributive property, and we end up with 6, the square root of 3, minus 12. In the denominator, we have the difference of squares, so that's going to be 3 minus 4. Combining our like terms on the bottom, we end up with 6, the square root of 3, minus 12, all over a negative 1. Distributing that negative, that's the same as 6, the square root of 3, divided by 1, plus the negative 12 minus 1, which will give us negative 6, the square root of 3, plus 12. Now, that's not quite in the form a plus b, the square root of 3. So let's rearrange this. So I have 12 minus 6, the square root of 3 for my final answer. On these, you need to write them in the form of your integer plus or minus the term with the radical. In example B, we have the same instructions, so we need to multiply the top and bottom by our radical conjugate, which is 3 minus the square root of 3. So we're just going to multiply straight across the top and then straight across the bottom. Multiplying our first terms together, we get 3. Outside terms gives us a negative square root of 3. Inside terms gives us a positive 6, the square root of 3. And our last terms give us a negative 2 times 3, or negative 6. On the bottom, we got the difference of squares, so that's going to be a 3. On the bottom, we have different squares, which is going to be 9 minus 3. Let's combine like terms on the top. We have 3 minus 6, and we have a negative the square root of 3, and a positive 6 the square root of 3, so that's going to be 5 the square root of 3. Results in negative 3 plus 5 the square root of 3 over 6. Now we need to write in the form a plus b the square root of 3. So let's break up the fraction. So that's negative 3 divided by 6 plus 5 the square root of 3 over 6. Simplifying that first fraction and bringing that number out, then writing the radical. We now have wrote this in the form a plus b times the square root of 3. For this next section, the instruction is going to be to write in simplest form. And in this section, we're going to look at adding and subtracting radical fractions. First thing you need to do is we need to rationalize the denominator of each individual fraction. So in this first fraction, I'm going to multiply by the radical conjugate, which is 1 minus the square root of 3. And then to rationalize the denominator in the second fraction, the radical conjugate this time is going to be 1 plus the square root of 3. So I multiply the top and bottom of the second fraction by 1 plus the square root of 3. And then we're going to do this just like we did the last problem. So we're going to multiply straight across the numerator for the first fraction and straight across the second fraction as well, multiplying our numerators together and then multiplying our denominators together. Okay, we're going to use our FOIL method, multiplying our first terms to get 1. And then combining the two middle terms gives us a minus 2 the square root of 3 over 3. I have the difference of squares on bottom, so that's going to be 1 minus 3. Plus, doing the FOIL method on the top, we end up with 1. And then doubling that in the middle, so that's going to be plus, and then plus 3. And we have the same denominator of 1 minus 3 because it's the difference of squares. Let's combine like terms. For the first fraction, that gives us 4 minus 2 the square root of 3 over negative 2. And then our second fraction, we're going to end up with 4 plus 2 the square root of 3 over negative 2. Let's break up our fraction. So we end up with 4 divided by negative 2, the negative 2 the square root of 3 divided by negative 2. Plus, breaking up the second fraction, we have 4 divided by negative 2 plus 2 the square root of 3 divided by negative 2. Then let's simplify each of these individual fractions. So that gives me a negative 2 plus square root of 3 minus 2 minus square root of 3. Combining like terms, a negative 2 plus a negative 2 equals negative 4, and the square root of 3 minus square root of 3 cancels out, so our final answer is simply negative 4. All right, let's do one final example. So this is just like the last one. So I'm going to look at the first fraction and multiply by the conjugate, the radical conjugate, which in this case would be 3 minus the square root of 5. Remember, I got to multiply the top and the bottom by the same thing. For the second fraction, my radical conjugate would be 3 plus the square root of 5. So the procedure is we're going to multiply straight across the top and straight across the bottom of both fractions. And practicing my multiplication of radicals we learned in a previous section. On the numerator of the first fraction, I should get 6 minus 2 the square root of 5 plus 3 the square root of 5. Minus 5, and the denominator, we have the difference of squares, so it's going to be 9 minus 5, plus, for the second fraction, we're going to do the distributive property, distributing that 2 the square root of 5 to each term, giving us 6 the square root of 5, plus 2 times 5, over our difference of squares again, which is 9 minus 5. Combining like terms in each fraction, the first fraction you end up with 1 plus the square root of 5 divided by 4. And the second fraction we end up with 10 plus 6 the square root of 5 divided by 4. Now last time when I worked these out, I divided up each individual fractions, like 1/4 plus square root of 5 over 4 plus 10 the square root of 10 over 4 plus 6 the square root of 5 over 4. Now I'm going to show you another way that you can do this. Since I have the common denominator, I'm just going to combine all of the top together, so I can write it as 1 plus the square root of 5 plus 10 plus 6 the square root of 5 all over the common denominator 4. Then combining like terms on top, I end up with 11 plus 7 the square root of 5 over 4. And then I can break up the fraction and write 11/4 plus 7/4 the square root of 5. Now you can either do it this way when I break up the fraction at the last step, or you can break it up earlier as I did in the previous example. You get to choose.